Hello students, I am Gurmeet Singh. In this lecture, we will do question number 5 of exercise 13.1 for class 10 students, chapter statistics. This question is very important, so pay your full attention. It will be interesting. In this question, in a retail market, fruit vendors were selling mangoes in the packing boxes, and the data is given with respect to the number of boxes and the number of mangoes. For example, if you observe this column, 15 number of boxes are having the number of mangoes in the range of 50 to 52. Similarly, if you check the extreme right, 25 boxes are having the mangoes in the range of 62 to 64. The different boxes are having different number of mangoes, and in this question we have to calculate the mean number of mangoes kept in a packing box. And which method of finding the mean did you choose? We have to explain which method we will use. Okay, so let's take down the question. Let's convert the rows into the column. We got our standard table. Before proceeding further, a small question for you. In this given range, are you able to find any error? This is our fifth question. You have done 4 questions. In comparison to all the 4 questions, is there anything different are you observing in this range? Take some time, observe, refer the previous 4 questions, just the data, and tell me what is the error, what is the difference with respect to the other 4 questions. This is very important. Okay, let's check your level of observation. Take some time, pause the video, then come back. So welcome back. Hope you have got that error. Let's see what is the difference with respect to the other 4 questions. If you observe this cell, it is given 50 to 52, and in the next cell it is given as 53 to 55. The data from 52 to 53 is missing. If you have covered our theory lecture in which I have told you 50 to 52, it means the range is from 50 to 52 and 52 is not included. 53 to 55, it means it is from 53 to 55 and 55 is not included. The upper range in the statistics are not included in the range. The same concept we have covered in the theory part. So here if you observe 50 to 52 is given and 52 to 53 is missing. Similarly from 55 to 56 it is missing, 58 to 59 it is missing, and from 61 to 62 it is missing. Let's try to understand this on a number line. Let's take a number line and let's have the number from 49 to 65 just for reference. These all are the number of mangoes. In the first case, 50 to 52 mangoes are in the number of boxes 15. So what is the range 50 to 52? This will be the range from 50 to 52. 52 is not included, so I have just kept the line slightly below 52. It is from 50 to 52 and 52 is not included. Similarly, 50 to 53 will be this range, 56 to 58 will be this range, 59 to 61 will be this range, and 60 to 64 will be this range. All these middle part are missing. In the statistics, whenever we apply all this mean formula, the direct method, the mean method, the step deviation method, the upper limit of the first row should match with the lower limit of the second row. In all the previous question, you have observed that the upper range of the first row is matching with the lower range of the second row. Basically, it means that we should not have any of the missing value. We should not have any of the gap. So how we solve this question? We will just increase the upper range by certain range, for example 0.5, and also decrease the lower range by 0.5. Let's see what happens. Firstly, let's increase the upper range of all these cases by 0.5 and also decrease the lower range of all these cases by 0.5. Now we got a complete case in which we are not having the gaps. Got it? For the first case, we got the range as 49.5 to 52.5. We have decreased the range by 0.5 and increased the range by 0.5. Similarly, the second range, it will be 52.5 to 55.5. Similarly, we have done for all the cases. Note that this will not affect anything on the data. Our data, the entity of the data will remain the same. For example, 15 boxes are having the number of mangoes in the range of 50 to 52. Got it? Now, can we say that 15 number of boxes are having the number of mangoes in the range of 49.5 to 52.5? Nothing is changed. The number of boxes are same and the number of mangoes are also same. It is only the range. So our data entity is not changed. Our data is same. Just we have played with the range. Got it? Just to enhance the example, we are having a box with 20 mangoes. We can say the range of mango in that box is between 10 to 30. Or we can say the range of mangoes in this box is from 5 to 35. Or the range of mango in this box is from 0 to 40. All these cases are true, the data is true, nothing is changed. Just we have played with the range. The number of mango in this box is 20. Okay, only we have played with the range. These type of questions are slightly twisted question and you should know this approach how to solve the question. You have to play with the range. Got it? Now we got our normal table with the number of mangoes and the number of boxes. Here the number of boxes are the frequency. That is how many times our observation are repeating. That is frequency, which is Fi. Let's apply the simple mean method to solve this question. Firstly, let's find xi, which is the midpoint of the observation, which is the range. So what is the midpoint of 49.5 to 52.5? It is 51. As usual, we can also use the formula lower limit plus upper limit upon 2, which is 49.5 plus 52.5 upon 2. Our answer is 51, which is the midpoint. Got it? Similarly, the midpoint of second range, it is 54, next 57, next 60 and 63. These all are the values of xi and all these values are looking slightly big. So we will go to the next method, that is the assumed mean method. And what we do in the assumed mean method, we find the deviation. But what is the first step? The first step is finding the assumed mean. Here if you observe all this xi value, the middle point is 57, which we generally denote as the assumed mean. That is A. We got A as the assumed mean and we subtract this assumed mean from all the values of the observation, which is xi, to get deviation, which is di. On solving, we got all the values of di as -6, -3, 0, 3 and 6. Here again we are having two options, either to go with the assumed mean method in which we calculate Fi into di, or we can go with the step deviation method. And how we check in which method we have to do? We see the class size. Here if you observe the class size in all these cases, that is H, the class size is coming as 3. That is 52.5 minus 49.5, the range, it is 3. So we got H as 3. And further, this 3 we can divide all the values of the deviation with 3. That is 3 is a common factor of the deviation. So we will proceed with the next method. That is step deviation method. Why? To simplify the calculation. Nothing special, you can apply the assumed mean method also, but here we are going with the step deviation method to further simplify the calculation. You can go with any method, the answer will remain the same. We are searching for the simplified method. Okay, so let's add one more column, ui. Let's divide all the values of the deviation with the class size, which is h, which is 3. So let's divide all the values of the deviation by 3. We got -2, -1, 0, 1 and 2. So we got all the values of the ui. So let's find Fi into ui. Let's multiply Fi with ui. In the first row, 15 into -2, it is -30. 100 into -1, it is -100. 135 into 0, it is 0. Next, it is 115 and 50. So we have multiplied Fi with ui. Let's do the addition to get sigma Fi into ui, which is 25. And let's add all the values of Fi, which is 400. Okay. We got all the values. Let's use the formula of step deviation method. Here A is 57 and H is 3. Let's put the value. Let's solve it. We got the mean, that is mean number of boxes as 57.19. That is the answer of the question. And next part, why we have used this to get the calculation as easier. Okay, nothing special. So students, we have done with this lecture. Hope you have enjoyed the lecture. If so, please like, share and subscribe. And also check out the description for various resources related to class 10, like the continuing lecture, the lectures related to other topics, and the PDF of the formula list. All this in the description, check it out. So that's it for this lecture. Thank you very much for being with CREATA Classes. Have a great day. Bye for now.